Okay, so linearization, here's our last day of practice. We're going to go through the same process. So students who like regimented procedural things usually are okay with linearization. And so it's not about the physics equation. No, we have not studied the period of a pendulum, the period of a object going in a circle yet. That's okay. We don't need to know the physics behind this equation, okay? And so it's all about the data. What do I need to do with the data to get a linear line? Y equals mx plus b it, right? So it says an experiment is performed using the apparatus to the left. A small disk M1, which they have labeled, let me get my draw here, which they have labeled as the one that's moving in a circle, just to differentiate. It's on a frictionless table, one end of the string. The string passes through a hole in a table attached to a narrow vertical plastic tube. An object of M2 is hung at the other end. So I only emphasize M1 and M2 because one's going to be constant, one's going to be changing. And that's what you need to know in procedure, what variables are constant, what variables are changing. A student holding the tube makes the disc rotate a constant circle, radius r, while another student measures the period, p. Okay, now it later tells us that the unit is seconds. And so just for today, just so you know, this is a time. Derive the equation that from this equation that relates p and m2. So it looks like, do you have a pass?
No, you need to get one.
You're supposed to when you walk in late. Okay, so it's about taking this equation, rearranging it to fit y equals mx plus b, using that m2 and p, which are the two things changing. And hopefully you look at the data table, because the data table is going to have the things that are changing, right? And so we're going to be changing the mass, and then you're going to record the time, the p, okay? It says this procedure is repeated, and the period p is determined for 4 different values of m2, where m1 is this mass. Don't get confused, that's m1, that's the one not changing, and the radius is 0.8. Now those are only one number, so both of those are constants. The data is presented and can be used to compute an experimental value for g. Hold on one sec, I've got to switch over now. And so we know that the end result, we should get G. Our final answer should be close to 9.8. So it's very similar end result to the very first problem we did, but it's using a different equation, different set of data. What quantity should be graphed to yield a straight line with a slope that could be used? Notice it doesn't say it's going to equal G, but it's going to be used to solve for G. And so how to linearize. So I need a little bit more room. So maybe I slide over here. And so here's the initial equation. And again, we're doing this one together. It just has the most variables, right? And we need to y equals mx plus b it. Well, does the original equation have plus or minus anything? What do we think is going to be true about, based on data, based on the main equation? What's going to be true about our y-intercept? It doesn't exist, or it's going to go through 0. So there's one thing we don't have to worry about. Now, again, I don't want you thinking 100% of graphs go through the origin. That's not a true statement. But in 90%-ish of your physics equations, most will go through 0. Okay, most, not all. And so remember, y is changing. That's our dependent variable. And then independent variable is the x, if we can make it happen, right? And then m is what? Is this m1 or m2? It's slope. It's neither mass, right? So be careful, look at context. M1 and M2 are masses in our physics experiment, right? But M in this math equation is slope. And for a linear graph, slope is constant. And so I need to group all my physics experiment constants together in the placeholder there. And so it's already solved for P period, which is a time. What do you think? Is mass or time going to be dependent or independent? Who's who? Does it make sense that P period time is on the y-axis? Yeah, okay, so it fits. So we can go on and just leave P alone. Leave it there. So what else is changing in the experiment that we're controlling? Look at your data table. What else is changing? M2 needs to line up with that independent variable. Well, look at all the other variables. 2, pi, M1, they gave us one number for. R, they gave us one number for. And then G, we know is a constant. Everybody else is a constant. And so I need to pull everybody else away from that M2 so that I can have them as a placeholder for slope. Now, at this point, do we to keep the square root or to get rid of the square root? And honestly, there's more than one way to do this. So if I had let y'all give this one a try, half of you would have kept the square root, half of you would have squared it away, right? Both can be correct. What do y'all want to do? First one calls dibs. Keep square root or square it away? Square it away, I hear. So let's square it away. If I square the right side of the equation to get rid of the square root, what do I have to do to keep equality? Square the left side too. And so I got to square even 2 pi. Square everything. Everybody gets a square, okay? Now that means I have P squared on the Y now, but that's okay. We can square, right? And so 4 pi squared would be what we get there. And then here, let's just do the breakdown. So we'd get P squared equals 4 pi squared. And then when you square square root, everybody else just stays right there. Again, I'm trying to get M2 away from the constants. We're separating constants and non-constants. Notice it's in the denominator. I can't change that fact, right? Oops. And so to pull it out, we would get P squared equals 4 pi squared times M1R over G times, because slope times X, right? What would you multiply to keep the equality? 1 over M2. Okay. Again, this isn't the only way to do it. It's one way to do it. And so now, if we compare it to the y equals mx, and I'm just spreading it all out, we've already said y-intercept equals 0. What are we going to plot on the y? P squared. What are we going to plot on the x? Inverse M2. Note our data table, why'd they give us 2 rows of blank? So that we can process this data. And then what is your slope equal? And I am going to go on and write out the word slope since we have M1, M2, and M. Our slope should equal that 4 pi squared times M1R all over G. Now this is the hardest part. Now that we know what to do, now we just inverse and we square and we plot and we slope and then we figure out what G is. By the way, we're probably not going to get 9.8. You rarely get exactly what you should get in a lab type situation, okay? Everybody good right now? Yes. So originally, right there, M2, we know we want it somewhere on the x-axis, right? Somehow on the x-axis. And so it's in the denominator. You have to keep it in the denominator to keep your equality, right? And so if you try to separate the constant things, variables, from the non-constant, well, what two things, mx, have to be multiplied to keep the equality? I can't just multiply by m2. I'm not trying to move it to the other side. And so I want to keep it on the same side, just pull it out of that group so that I group my constants. All of these are constants, but m2 is not. And so it has to stay in the denominator because that's where it is. That's how you keep your equality. Okay. Any others? All right. So to answer their question, what quantity should be graphed to yield a straight line? We're going to have p squared versus inverse m2. And so we'll have y versus x. Well, they only gave us p and m2. We need to go process that information. So calculator's ready. They have mass 2 first. So I'm going to put my inverse m2, which would be an inverse kilogram. And so all those m2s go through and say inverse. So 1 over 0.02, I get 50. 1 over, aren't these so nice? Until now, I get 16.66666. Remember, we are going to be the ones plotting these, so I would be nice to your graphing self. No one else has, 2 decimal places, so I'm going to round to 17. Or you use Excel. Now this one we might be able to estimate to the nearest half. I don't know. Sounds contradictory, so we'll be ready for both of those numbers. We'll see how we scale it. And then for P, we want to square all those numbers. So P squared would have a unit S squared, bless you. And so 1.4 squared, it rounds to 2. 1.1. Maybe we'll be able to plot. Those numbers do look small enough. Okay. Questions on the process data. We used the raw data. We did something to it. All right. On the grid below, plot the quantities that we determined, label the axis, draw the best fit line. Remember, do we play connect the dots? No. Ruler ID, I'm going to use the line tool here in OneNote to get my best fit line. And then we already used the blank rows to record any values. And then the last thing, use our graph, hint, hint, use the slope to calculate the experimental value of G. And if you look at our y equals mx plus b equation, we had that slope equaled 4 pi squared times m1r over G. Now I know we don't know the slope yet. Could we go on and solve this equation for G so we know what to do once we do have slope? How would I isolate G? Multiply both sides by G, right? Then divide both sides by slope. And again, I am keeping the word slope just so we don't mix up M, M1, and M2. Those are 3 different M's. And so we get G is equal to 4 pi squared times M1R all over slope once we know it, right? Remember, they did give us M1 and R. Those numbers never changed. Okay, so let's go do our graph. And so we said we're going to put P squared on the y-axis, and our biggest p squared number is 2. And so we've got what? 5 darkened grid lines there. So just because I learned my lesson last week with 5 divisions of 2, that'll get a little weird with 0.4, 0.8, 1.2. Do it if you want, but I'm going to put 2.5 as my max. I love graphing. If anyone can have a favorite, my favorite way to scale is in 5s and 10s, okay? So, and then on the x-axis, we're going to put that inverse M2, which is an inverse kilogram. And I think our biggest number was 50. And so that one will work out. We've got 5 darkened lines. So I'm going to go 10, 20, 30, 40, 50. Okay, so notice each small grid line is not the same on the x and y axis. Just be careful. Don't say 1 box over 2 boxes. Slope is 1/2. Don't do stuff like that. And now we plot our process data. And so I get an inverse mass 50 with a p squared value of 2. That one's nice to plot. Again, not too little, not too big. Goldilocks, just right. And just keep it going. I got 25 and 1.1. And thankfully, the way it's scaled, 1.1 is 1 little grid line above 1. And 25, though, is in between 20 and 30. (17 and 0.64). So 17, be careful on your x-axis. Those are in 2s, right? So this is 18, 16. And I've already forgot the other number, 0.64. Bless you.
Thank you.
So a little bit halfway, a little above the 0.6. And then 13-ish, 0.56. Nope. And don't force it, but think about it. Should this best fit line go through the origin? Based on y equals mx plus b, the main physics equation did not have plus or minus anything. So it should go through the origin. And so now I'm going to go grab my line tool. If you're working on paper, ruler ID. Okay, don't just connect the dots, because notice here, you might get zigzaggy. And so the art of the estimation that I was doing to hand plot is going to kind of be okay now that I'm doing a best fit line. Okay. And by the way, once again, AP exam in May, graphing, use pencil. Okay. Because if you mess up, you want to be able to fix it. And so I am going to include the origin. And I'm not necessarily connecting first and last points. I'm going to release it right there. So technically, this one for me is not going through any of the data points. Again, you don't want to find slope using your data points. You're doing the slope of the line. The points get your line. You're done with the points. Now to get the slope of the line, again, AP wants you to use at least half the available line to do the slope. And so I'm going to come in here and find a couple of points. And again, I try not to use the origin. I don't want you thinking you always use the origin. And I definitely won't be using my data points, but try to find a couple places that are on the grid line so that you can more easily get it. And I see one here at the end. And then I'm going to look about halfway on the line away. I see another one, bless you, about right there. And again, this is a working graph. It is okay. You don't want to clutter it up so much that they can't see your original, right? But I usually do the number stuff off to the side. But this is my run and my rise. I'm going to bring them down to help me read it. And so I'm going to get those points on the y-axis. It looks like I start at 0.8. Nope, 0.9. Read it right. And then it ends at 1.8. In my x values, that's 22 to 44. Double check. Yep. And then I'm going to go down below to do my slope. So that rise over run. I get 1.8 minus 0.9 over 44 minus 22. And so 0.9 over 22. Now, could you do all this in your calculator? Yeah, you could even put the data there and produce the graph with a graphing calculator. Can your AP grader, not just me next week on the quiz, but can your AP grader grade what you do in the calculator? No. And so just view our exams, view the AP exam as proving your knowledge of physics. You got to give them something, okay? If they want a graph, if you do it all in the calculator, you're not going to get all the points. They want to see the graph. Now, to get the slope, if you let the calculator do it, make sure you tell the grader that you're doing what, linear regression or something in the calculator, and then put what you get for the slope. Me, a little old school. So I get a slope of 0.04091. And yes, I'm going to use all that. This is not a final answer. And this isn't something that I'm going to go plot. So I'm not going to try and plot to the fifth. I like, when you deal with really small numbers, use as many decimals as you can handle. Because if I round that to 0.04, then that's going to be maybe affecting my final answer, okay? You can try it both ways here in a little bit. Everybody okay? Okay. So now, to solve for g, we'll do 4. And for pi, you can either, use the button, which that's what I tend to do, or you can type in 3.14, okay? But watch out, the 4 has already been squared, but pi needs the square. Times m1, which I got to go back up, they did give it to us, 0.012, and the radius is 0.8. So 0.012, and then 0.8 was the radius. So whatever that all is, divided by as many numbers as you can handle there, okay? I like 3 non-zero digits. That's my reasoning. And so 4, there's the pi button, squared, times 0.012 times 0.8 all over, dun, da, da, da. Again, we should have got close to 9.8. So if you get 9.3 and you're like, oh, it's not close enough, okay, maybe go back. Did I plot it the best? Did I get the best fit line? To me, for today, that's close enough. The physics, the process is there. It's not always about the final answer, okay? If you get 2, if you get 3, if you get 6 or 7, definitely I would say some kind of mistake. But if you get in the realm of, 9.8 plus or minus 1, you're okay. Did you have a question? No? Okay. How do we feel? Went through the same process, right? Identify what's constant, what's changing. If you want to make independent dependent happen, make it happen. It doesn't have to happen, but the way I look at it, if I can make it happen, why not? Okay. Okay, so here's what I want you to do. Small group, right? So make sure that you are working together. Don't make just one person do all the thinking, right? Work together. And so you can either work in your, group of 2, group of 3, group of 4, beware. Don't be the 4th person not contributing, okay? Maybe we start the first problem in pairs. But go back up, try that other MGH question. Your data table is different. The independent dependent stuff, the things that are changing, what your slope equals is different. Okay. And then there's 2 more at the end. F equals MA. That's an easy enough equation, but be careful. It's not in Y equals MX form. Just FYI, you got to move things around. And by the way, the answer on that one I have should be 20. And then the last example, ooh, there's another square root business. What? And you're going to use your slope to determine the gravity on Earth. Gee, we know what that should come out, right? I didn't put a final answer. Hopefully you know what the acceleration due to gravity is. 9.8. Good deal? So the quiz is on Monday, next class. Be ready to do one of these with a new equation, one you've never seen before. Don't let that freak you out. Do you need to know about pendulums to do this problem? No. Okay. All right.